Hello and welcome to CS230. This is lecture 14 and lesson 1, and in this particular lesson I'm going to review some of the entity relationship modeling notation and key terms. We're sometimes refer to this as database modeling, and for my module I assume that you're already familiar with designing and implementing relational databases using something like MySQL, because it's a requirement for the module that everybody has done a database module, but everybody gets a bit rusty when they're not working with database technologies all the time. So this little lesson is just going to give you a brief overview then of the key terms that you need to know about when you're designing ER diagrams, or ERDs, entity relationship diagrams. Now, there's one, you can see it on the screen at the moment. Here's an entity, and then here are the relationships, and I'm going to go through what it means, what all these various elements means as I work through this particular lesson. So one thing to note is that there will be some inconsistencies with what you've already learned in your database modules, and in fact that particular database module may have used a different notation to represent an entity or a relationship, or what we'll see this a little bit later, these are called the cardinality rules. But that doesn't matter. Like when the differences arise, refer to your core text and resource on data modeling and database design, and use whatever you're most comfortable with. Really, the lesson is about providing you with just enough background on the topic so that you can understand the design that follows in the next lesson. Okay, so this is a sample entity relationship diagram in ERD for customers. We're interested in customers in this particular app, and we're interested in addresses, and we're interested in maintaining customer addresses. This stuff on the right here, this table on the right, and this table down here to the right of this one, they're just about auditing, and we'll see a little bit later. But first thing we have to do is talk about data modeling. Okay, so there are 3 levels of abstractions for data models that are involved when you build ERDs. There's the conceptual, the logical, and the physical levels of abstraction. And sometimes you then see something referred to as a conceptual model, or a conceptual ERD, or a logical model, or a physical model. And we'll see all 3 of them as we work through this. Well, we'll mostly see the logical and the physical, because I tend to roll the conceptual and the logical into one for web dev. Okay, but typically a business analyst, they use the conceptual and logical models to model the business rules or business objects that exist in some system. And then when all the entities and relationships have been identified at this level, when they've been finalized and agreed upon by everybody, then the database designer or the engineer uses these. That's the conceptual and logical model to produce some physical model that can be used to create a database then in MySQL, say. And so every single one of the ERDs, or the phases, conceptual, logical, physical, has an ERD associated with it. And this one here is mostly a logical ERD. Okay, so the differences between them is that the conceptual ERD models the business objects that exist and the relationships, and it defines what entities exist, not about what tables exist. The logical model then actually explicitly defines the fields or the columns associated with each entity, and the physical model actually is a design for the relational database, and it explicitly elaborates on the logical ERD. Okay, so for our example, we're going to work with really small systems, and they don't require complex modeling at all. We tend to combine the first 2 phases into one phase, providing the logical overview. And then when we have the logical overview, we produce a rudimentary model directly from that, or we just go straight into PHP-MyAdmin and work from there. And that's the approach that I'll be showing you. I'm just going to take that ERD that we have up here, and I'm going to build something directly from PHP-MyAdmin. Okay, so if you're unsure about that, there's a couple of nice resources here. They're very accessible on data modeling from Visual Paradigm and Code Project, and I've used them as references in this lesson here. Okay, so let's review some of the key parts then. So entities, we talk about them already. That's some real-world thing. It's easily recognizable, and it's non-recognizable thing, or some concept. It's anything in the enterprise that's to be represented in our databases, okay? And it can be person, place, object. So you can think then of entities having attributes, and they're things that describe the entity. So when you think about entities, think of them as kind of like the nouns in your system, okay? The person, place, or thing. So independent entities are those that can exist without some other entity, and then dependent entities, they rely on the existence of some other ones. So some of the attributes are taken from the identifiers and the entities in which they depend, okay? So we sometimes read about ID-dependent entities, and they're entities whose identifier, or the key identifier, includes the identifier of another entity, and that's a weak one. Okay, so a weak entity is an entity whose existence depends on the presence of another entity, and a strong entity is an entity that isn't weak. Okay, and weak entities don't have key attributes. And really, they're about, like, uniquely identified. They can be uniquely identified by having a primary key from some other entity. Okay, so they have to participate in some kind of relationship. Okay, so if you think about a library, borrowers and books could be entities, but a loans entity would be weak or dependent because it only exists as a result of a relationship between borrowers and a book. Okay, and in our example up here, we can see we have a customer and an address, and a customer address. They're physical. These are two physical things, and and a customer address is that association between the customer, the address, and they have an address. Okay, so that's not too bad. Okay, so relationship then is an association among two or more entities, and entities take part, or they're sometimes said to participate in relationships. And we normally associate relationships with verbs or verb phrases. So we see, for example, up here that this customer keeps an address. Okay, so that's that's our relationship. Okay, and attributes then is a single valued property or characteristics of some entity or a relationship that holds it. So a book might have attributes like a title, a publication date, an ISBN, etc. And attributes can be simple. That means they're atomic. In other words, they can't be divided down any further. So for example, a contact number, you might have composite attributes, and that means it's possible to break it down into small atomic elements. So a customer's full name could be broken down into first name and last name, for example. Attributes could be derived. That means it's not included in the physical database. So, for example, you can determine age from a date of birth attribute, okay? And also attributes can be multi-valued, and that means that the attribute can have more than one value. So a customer could have more than one phone number, more than one email address. So when we think about the physical design, then these attributes ultimately make their way. Some of them make their way into keys. Okay, so what we tend to do, we take our entity relationship diagram and then we represent the attributes as database columns in a table. So the rows in the table then are records, and that reflects some instance of an entity or relationship. So you might have a specific entry in your database for a book or a customer or a person. Okay, but you need to be able to uniquely identify that particular instance, and so really, for example, there can't be, so you need some attribute or key attribute value that is not shared by anybody else, and that key attribute is often referred to as the primary key. Okay, and look, there may be more than one unique attribute that could function as the primary key. So for example, your mobile phone could, and your name could be, or your social security number could both identify the same person, because two people wanted the same mobile phone, or maybe they would, or maybe people might share. So these are ultimately become candidate keys. So that's all the attributes that possibly could be a key. So a foreign key is a reference to a primary key in a table representing some collection for some specific entries. So you can have more than one foreign key in a table, and they're used to identify the relationship between entities. So if we go back up to look at our little example here, here's a customer. It has a customer ID that's a primary key. Here's an address, and it's a primary key. And here we have customer address table, and that associates the customer ID and address ID as foreign keys. So it's not too bad. So you may actually have, let's say you have more than one way of uniquely identifying. So you could actually, once you've chosen the primary key, so for example, you could produce something called an alternate key. So for example, like the customer, and you can see it here, that has a number of columns, but you could actually, we've decided that customer ID is the primary key, but we could actually say that first name, last name, and date of birth probably and uniquely identify somebody as well. So that could be an alternate key, for example. And so that's why we refer to them as AK. So the combination of those columns, or we might have an email address might be a way to identify that customer, and it's another alternative key. And we could say a mobile number could also be an alternate key. And we're assuming, of course, that these aren't shared, okay? And it is perfectly possible that somebody could be born on the same day and have the same first name and last name, of course, but that's how it works. So this one here, this alternate key, combining these three columns, it could also be called a composite key, for example, okay? So sometimes we actually have something in records that we refer to as a natural key. And that's kind of a key that exists in the real world or some business purpose, but doesn't actually end up being the primary key. Okay. And additionally, I'm getting through all the keys here. Okay. A surrogate key. That's the name given to a system-generated candidate key that's been made the primary key. Now, we tend to do this a lot. So that, for example, when we create the physical database, we actually just assign the customer ID to what the next record number for that particular table, and that's a surrogate key. So it's very often that you might see something like a surrogate key would be would be one that's used in your database tables when referring to individual instances of a record in a table. Now, if we were a revenue or something like this, their customer ID might be their PPS number, for example, but that could be their primary key, but you might also have an alternate key which refers to their record in the database, for example. So I tend to use those, okay? I tend to use those auto-generated surrogate keys as my primary keys in my tables, and you'll see that a little bit later. So as you can see, so we refer to the primary keys as PK, we use AK for alternate keys, and we use FK for foreign keys, and then we can actually implement to create a table, and we can set up the primary key usually as part of that when we do the physical design, and then we use the alter table SQL commands in order to be able to set up the alternate keys. So what happens is that when we enter somebody's name, we create a record, we enter the record into the database, and then we create a new record, or we have a new record. Somebody else tries to register with our system, and they have the same. If it's the same, if somebody tries to register twice, they give their same name, first name, last name, same date of birth, and then we have a constraint on the table to say, there's a uniqueness associated with this, and we don't allow that entry into the database, and we can handle that error then, for example, in our application. Okay, so some really useful resources that I've used to write this, apart from the core texts, of course, which you need to know. But there's a great introductory article on the visual paradigm here, and this particular reference from Code Project gives nice examples of 3 different kinds of models. It shows the difference between the conceptual, the logical, and the physical module, and that's a really nice article. It's more of a book really on notation and design, for example, and I've given the link here to the cross-foot notation, and we look at that in the next lesson. So in summary then, we've looked at the basic elements in database modeling and design. We're going to need to know this, we're going to need to know the terms in order that we can do entity relationship modeling, and we'll need it for our next couple of lessons. Thank you for watching.